The activity will be to figure out how interior and exterior angles are related to each other and how they depend on the number of sides of the polygon. Okay, so you'll need several sheets of paper, preferably in different colors, a ruler, and a pen or pencil, and some scissors, and preferably some tape. Okay, so first let's draw a triangle. Everybody should be drawing a triangle that looks kind of a little different from everybody else's. Start with a point somewhere on your paper. Draw a ray, that is a half line that goes off the edge of the paper just in one direction. Now turn your paper, mark a point on this ray, and then decide on another direction that starts from that ray and goes off the edge of the paper. Now choose a third point, possibly turning your paper, on the ray. And this next ray has to start at the point you just drew and go through the first point that you started with and then off the edge of the paper. Okay, so you should have a triangle that looks kind of like this. Your paper should be divided into a triangle and 3 extra pieces. And it should have sort of a spiral flavor, that my rays are kind of turning like this, like that, and like that. Further check is each vertex, if you look at your peekaboo hole, should look like a line straight across plus 1 sticking out. Add to 180 degrees. Okay, so before you begin cutting, label your points, and I think I'm going to label them on the straight line side of my line. So let's call that A, B, and C. And each of these points has 2 angles at it. So point A has an interior angle, so I'm going to write interior at A. Here's an angle marker. And there's also the exterior angle. That's kind of the rest of here. So here's the exterior angle at A. Here's the interior angle at B, and the exterior angle at B. And C has an interior angle and an exterior angle. So you may want to pause the video while everybody does this. Okay, once everybody has got their triangle ready, now cut along the 3 rays that you made. So again, you should end up with a triangle and 3 extra outside pieces. And the more accurately you cut and the more accurately you did your lines, the better it will come out. I'm being a little sloppy here. Okay, so there's my triangle with 3 angles, interior angles marked, and then my 3 outside pieces with 3 angles marked. And just ignore the angles that are on the edge of the paper. Now let's start with the exterior angles. So I'm going to add them physically, which means putting their vertices together and lining up the sides so one continues after the other one ends. So there's A, there's B, continuing with C, and is that a surprise? It seems to fill up a complete turn, complete circle, or 360 degrees. Was that true for yours? If it was true for everybody, that's a suggestion that it will be true for any triangles. The 3 exterior angles of a triangle add up to 360 degrees. Okay, how about the interior angles? You probably remember this from some long ago geometry class. I'm just going to tear them to separate the angles, and I'm tearing them because I don't want to confuse these with any other angles that I might create by cutting. Okay, so add the angles physically, matching vertices. Here's A, B, and C. And it doesn't fill up a complete 360-degree angle, but it does seem to make a straight angle of 180 degrees, or a half turn. So was that true with your triangle? If so, it suggests that in any triangle, the sum of the three angles, interior angles of the triangle, add to 180 degrees.